Hi guys, today I am going to start going over statistics in a little bit more detail. So from this point on, I'm going to start going over new concepts in these videos, so concepts that we have not been introduced to in class. The reason that I'm doing that now is because we've officially been told that we're not going to be going back to school for the end of the year. By going back to school, I mean going back into the classroom until next year, essentially. So all learning is going to be held online. So now I'm going to just start introducing new concepts and treating this like normal school, new concepts every day, and finishing out the modules. We will still probably have a few more review videos, but I need to make sure that I get all of those concepts that you need to know in 6th grade in before the end of the year. So we kind of started going over statistics already when we did mean, median, and mode. I mean, we really did start going over statistics. And mean, median, and mode is a huge foundation for statistics. It's going to help us with all of the concepts that we're learning for the rest of this module. But I'm kind of going to go backwards a little bit and start going into what even is a statistical question. So I gave you an example of what to do with answers, but I never went over what even is a statistical question. So a statistical question is any question that can be answered with multiple erase what I just said. Is any question that you could expect multiple people to answer with different answers. So this is a question where you're asking about multiple people or multiple things, and you can expect some variance in their answers. Variance just means some differences, okay? So I'm going to give you an example of what is a statistical question and an example of what is not a statistical question. So I'll start with what is not a statistical question first, okay? So if I said, how old are you? If you're in my class, you're probably going to answer 11 or 12. There is only one answer that you can give me right now, because at this moment, when you're answering this question, you are only one age, right? There is no variance in that answer. You're going to give me one answer, and that's the only answer that you can give me. Versus if I said, how old are the kids in my class? I have multiple kids that I'm surveying now. Now I have 20 kids that I'm surveying, and I can expect differences in their answers because not every kid in my class is 12 and not every kid in my class is 11. Some kids are 11 and some kids are 12. So when I'm asking a question where multiple people are sampled or multiple people are asked and people are going to have different answers, that is an example of a statistical question. Versus when I say things like, how old are you? What's your name? What's your favorite food? You have one answer there, right? A way that you could turn that into a statistical question would be like, how old is the class? On average, how many letters are in the names of the kids in the class? Or what was the last one? What are the 6th graders at Rob Road's favorite foods? All of those questions are going to have multiple different answers. You're not going to expect everybody to have the exact same answer with those questions. And all of those questions require you to ask more than one person for their answer or for their thoughts. All right, so I've kind of already used this as an example, but a statistical question that I could ask is, how old are the people in my class? So if I'm surveying my students, I don't have them here with me, obviously. I'm sorry, I miss you guys. I would assume that probably most of them would be 12, and then a few would still be 11. But for the sake of this, I'm just going to say half are 11 and half are 12, because that'll make it a little bit easier for me. I have 20 kids in my class. Half of that is 10. So I'm going to have 10 kids who are 11, 3, 4, 5, 6, 7, 8, 9, 10. And that would mean that I had 10 kids who are 12. So I have 12, 12, 12, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's somebody else that we have to think about that is in the classroom, and that's me, right? How old am I? My age would have to be considered in this question. How old are the people in Ms. D's class? I'm a person in my own class, right? So I would have to be considered as well. And I am 26. When you have a bunch of data or a bunch of numbers that are, or answers, I guess would be a better way of saying it, that are really similar to each other, and then you have one guy that's like way out there that's like, wow, you are going to totally mess things up. This is called an outlier. So anything that's like way different than the rest of the results that you got is considered an outlier. since I'm obviously the only adult in the classroom, I'm the oldest person in the classroom by far, I am considered an outlier. The same would be true if we brought a baby in the classroom, right? If I brought a 1-year-old into the classroom and then I counted their age in my data, that's going to completely throw things off. And I kind of want to show you how that works. So what I'm going to do is I'm going to find the average or the mean of the data set with my age and again without my age. And remember, in order to find mean, I should probably do this in another color. In order to find mean, we add up and divide. So we add up all the numbers and then we divide by how many numbers we have. So I actually want you guys to pause this and I want you to try and find the mean of this data set on your own and then come back when you have it. All right, welcome back. Okay, so my first step that I'm gonna have to do is I'm gonna have to add up all of my numbers and then divide by how many numbers I have. So I know that I have 10 11s. Instead of just doing 11 plus 11 plus 11 plus 11, I'm gonna do 11 times 10, which is 111. And I also know that I have 10 12s. And instead of just adding that up, I'm just gonna say that that's 120 because I know that. And then I also have me over here who's 26, right? And so I'm gonna add all these together still, and I'm gonna do 110 plus 120, which would be 230 plus 26, which would be 256. So my total, if I added all of our ages together, the number I would get would be, sorry, it's way down here, you can barely even see that, it's 256. Now, that number is not helpful on its own. I still have to do the next step, which is to divide by how many numbers I have on this board, right? So I told you that I have 20 kids in my class, and then there's me. So total in my class, there's 21 people. So if I wanted to essentially like gather up all the years and then evenly distribute them so we're all the same age, what I would have to do is I'd have to combine them. So 256 divided by 21. If you have not done this step yet, pause it and do this step, please, and then we will go through it together. All right, welcome back. Okay, so now I am going to do the division process. So 21 can go into 25 one time. You could have made a chart of your 21s. I would do that usually, which would be 21, 5 minus 1 is 4, 2 minus 2 is nothing, bring down that 6. 21 can go into 46 2 times, it's 42, minus 4.0, 21 can go into 40 one time, 20, and it's going to keep going. So I'm just going to stop at 21 and 1/10, or 12 and 1/10 for this. 12 and 1/10 as the age, okay? So that's saying on average, the kids in our class are about 12 and 1/10 of a year old. That's probably older than that. I mean, that is. So if I'm just using 12 by itself, I didn't say like some of the kids are 12 and 3 months. I just said 12. This is technically saying that this is older than my oldest kid that I listed. So in my list, this is technically older than anybody that I wrote down because I didn't talk about the months. So this is a number that we don't have on this board. I'm not 12 and 1/10. They're not 12 and 1/10 of a year. They're not 12 and 1/10 of the year. Nobody is 12 and 1/10 of the year, right? So this is older essentially than all of the students. This is older than every single kid in my class, and it's younger than me. Now I want to see how that data changes when we don't have an outlier, aka I am not in the mix. Okay, so now I have erased myself from the equation, and now I have still my 11-year-olds and my 12-year-olds, and I still know that that's going to be 110 and that's going to be 120. So now I'm going to just add these up to get 230. And like I said, there are 20 kids in my class, so I'm going to do 230 divided by 20. I could also have checked that by just counting how many numbers I have. So 20 can go into 23 one time. 23 minus 20 is 3. Bring down that 0. 20 can go into 30 one time. 0, 1 decimal. 0. 20 can go into 100 5 times. Sorry, I did not give myself enough space here, but I'm finished. My answer is 11.5 or 11 and a half. So now we're saying that the average age of people in my class is 11 and a half, which is honestly a lot closer to what my data shows. I didn't have any kid that was 12 and 1/10 on my board. I didn't write that down. I didn't have 12 and 1/10. I didn't have any kid that was over 12 besides me. I just kind of skewed that data. Versus 11.5 is a lot closer to what we actually see in terms of the kids in my classroom. It's a lot more fair to say that the kids in my classroom are 11.5 than they're technically older than 12, because that's not true given the data that I wrote on my board. So what I'm trying to prove here is that just one person can totally affect the data, or one number or one result can totally skew the data. And I'm only 26, and you guys saw how much I skewed the data. So it went from 11.5 to 12.1, or 12 and 1/10, which is actually a really big difference when we're talking about this, right? So imagine if you had a teacher that was, say, 100 years old and you included them in the sample. I want to just show you guys how much one answer or one participant can completely change your data. So let's say that the teacher is 100 years old now. We still know that this is 110, this is 120. Now we want to add this 100-year-old. So now we have 330 divided by 21, because I still have 20 kids in my class plus my one teacher, so 21. And I'm going to do 21 can go to 23 one time. Bring down that 0. 21 can go into 125 times. I'm going fast through this because I'm just trying to kind of prove a point. 5.1.0. So we're getting, I think that would be, let's see, 21 times 6, 21 times 7. Okay, so 7. I'm going to stop there because I've proved my point now, because the answer here is 15 and 7/10. Is anybody in my class 15 years old, almost 16 years old? No, the teacher's for sure not almost 16, and none of the kids are almost 16. Nobody in this example is almost 16. So this would be probably a more accurate sample if I got rid of my outlier, because my outlier, aka the teacher, is completely changing the results of my data. All right, so one thing to do when you have an outlier in your data set is to use a different way to find your center of data. So when we talked about mean is an example of a center of data. It's kind of like if I were to just ask you like about how old are the kids in the class, 11.5 is a fair answer, right? 12 and 1/10, still a little iffy. 15 and 7/10, definitely not right? So in that situation, I would use something besides mean to answer the question. This would be when I start using like median or mode to answer my question, because I have an outlier that skews the data so much. So if I were to find the mode of this data instead, I can still have my 100-year-old teacher or my 21-year-old teacher. Honestly, this part, they're not going to change the results whatever age, so I'll stay 26 for now. The mode, remember, is what happens the most. That's the most common answer. Well, I have 10 kids that are telling me that they're 11, and I have 10 kids that are telling me that they're 12, and I have one teacher that's 26. These are obviously far more common. These are happening a lot more often than 26 is, and they're both happening 10 times. So in this situation, my mode would be 11 and 12. Would you say that 11 and 12 is a pretty fair answer for about how old are the kids in your class or the people in your class? I would say that's a really fair answer, because my kids are all 11 and 12, right? I'm the only person that's not. So I would say mode would be a really good tool to use in this situation, because it's giving me a far more accurate answer. I could also use median. So median, remember, is that middle number. Remember, your median is that thing that's like in between the lanes on the highway. And in order to find the median, remember, I cross off from the bottom, I cross off from the top, but we have to make sure that our numbers are in order from least to greatest. I wrote my numbers in order from least to greatest, so this is going to be easy. But in order to solve this, remember, I'm starting 1 from the bottom, 1 from the top. By bottom, I really mean smallest number, the biggest number. Now I've crossed that off, so 1 from the smallest number, 1 biggest number, smallest number, biggest number, smallest number, biggest, smallest, biggest, smallest, biggest, smallest, biggest, biggest, smallest, biggest, smallest, biggest. And now we have our median, which we found the only number left over is 12. Do we think 12 is a pretty fair answer for about how old are the kids in the class or the people in the class? I think that is too. Mode and median are going to get me a lot more accurate results in this case where I have like a really big outlier than say mean would. So mean, median, and mode, we're using them all because they all have different uses. They're all useful at different times depending on the statistical question that you're asking and what makes the most sense given the questions that you're asking. Okay, when we are asking statistical questions, there's two different types of answers that we can get. We can either get categorical answers or we can get numerical answers. When I was going over mean, median, and mode, I focused on questions that only had numerical answers. And that is questions that can be answered with a number. So when I say things like, about how old are the kids in the class, that's numerical. I'm going to give my answer as 26. My students are going to give me the answer as 11 or 12, right? Your answer is going to be in a number. Versus if I tell you or I ask you, what are the favorite foods of the kids in my class? You're not going to tell me 7 is your favorite food, right? No, your answer is going to be in words. So that would be an example of a categorical question. So the way that I remember this is that numerical sounds like number. So I just remember numerical, number, and then categorical, the only other term, is words. So I want to think about different examples of statistical questions and whether their answers would be numerical or categorical, or whether the question would be numerical or categorical. So if I said, what is the average price of bread at a grocery store? If I'm asking you for price, you're going to tell me something like $3, $5, $6, however much it costs, right? All of those are numbers. Those are all numerical answers, which means that is a numerical question. Versus if I said something along the lines of, what color are the eyes of the kids in my class? Or what color are the eyes of the kids at Rob Road? If I ask you your eye color now, you're probably going to tell me blue, green, brown, hazel, right? All of those are words, so that is an example of a categorical question. The reason that that is important is because whether you have numerical data or categorical data depends on what you're going to use to find the average or that center of data. So we talked about mean, median, and mode, right? And I told you that mean is when you add all the numbers up and you divide, median is when you find the middle, and mode is what's happening the most. But if I'm talking about words, I can't add words together, can I? And I also can't line words up from least to greatest. So we'll talk about that a little bit later. Which one do you think would make the most sense for categorical data? All three different types, mean, median, and mode, have a time when they work best. All right, so if my answer is categorical, I'm going to think about like possible questions and possible answers. So let's just say like, what is the most popular sport for the students in my class? And I'm going to completely make up my answers, so I'm sorry if they're not right. So I'm going to just pretend, well, first, before we even start, right? If they're going to tell me their favorite sport, they're going to tell me something like basketball or soccer or baseball or whatever it is, right? They are going to be giving me answers in words, so we know that this is a categorical question. Their answers are not going to be numbers. Your favorite sport is not 12. It's probably one of those things I just listed, or something similar, right? So I'm just going to make up answers here. Let's just say 6 kids told me basketball, 4, 5, 6. 8 told me soccer, 1, 2, 3, 4, 5, 6, 7, 8. How many? 8, 6, 14. So let's say 3 told me, so I want to use something that doesn't start with a B or an S. Track. Or let's do 4. 3, 4, and let's think of another sport here. 2 told me cheerleading. This is the best I could come up with. I'm sorry if I didn't include your sport. But typically when I ask this question, it's about all soccer and basketball anyway. So this is probably pretty similar to what I'd see. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. Good. I wanted to make sure that I had 20 because I have 20 kids in my class. So I have 20 answers here. And I kind of just went over this, but can I arrange those in order from least to greatest? No. There's no value to these, right? There's no numerical value. I have no idea what is higher, what is lower, because you can't order these. You could order these from your least favorite to your favorite, but that doesn't mean anything in statistics. So if I can't order it from least to greatest, that's automatically knocking off median, right? I can't find median if I am not able to order them from least to greatest. I can't add basketball and soccer. I just can't do it. That's not helpful. So I can't find the mean. So the only thing that would really be helpful when answering this question would be mode. So when finding mode is what's occurring the most, or it's the most popular, right? And that's kind of what I'm asking you here. What's the most popular sport for kids in my class? So in order to solve this question, or in order to answer this question, I'd first have to go through and look and see, well, how many kids answered each way? I kind of just went through this, but bear with me here. So we said 6 kids said basketball, 1, 2, 3, 4, 5, 6. 8 kids said soccer, 4 kids said track, and 2 kids said cheerleading. So what's the most popular answer here? Well, the most popular answer was soccer. The most amount of students answered soccer. So if I were to ask you the statistical question, what's the most popular sport in Ms. D's class, my answer would be soccer. I'm using mode because I can't use mean or median, and I'm basically just finding out which one would be the most popular. So going through this, we've seen examples kind of 3 separate problems where they would all 3 have mean, median, or mode that would work the best. If I'm talking about my students asking about how, or what on average, what age are the kids in Ms. D's class, or what age are the people in Ms. D's class, we know it's not going to be mean that's most effective if I'm being counted. I throw off the data. I am an outlier. So when I'm counted, either median or mode is the most effective. When I am out of there, when they are not counting me, they threw out my data results, the 26-year-old doesn't matter, now mean is the most effective. That was when we got that 11.5. That's the most accurate age in terms of about how old are the kids in your class. Versus if I say something that has a word for an answer, mode would be the most effective. So when I'm counted, when I'm an outlier, it's like median. When I am not counted and all the data are very similar and they're all numbers, that would be mean. And when we're using words, mode would be the most helpful. As you can see here, they all have their uses. So you do have to know how to use all of them because they're all going to be most beneficial in certain areas. So if you're asked any sort of statistical question, it's important to know which one of the answers makes the most sense and which one of the strategies you should use in order to find that answer. The next thing I'm going to be going over is MAD. And in order to go over MAD, we are going to have to we're going to have to remember how to find the mean. So what I'm going to ask you to do is make sure you rewatch the video where I go over mean and make sure you are feeling really confident in finding mean before I go on to my next lesson. So if you need, so if you need to rewatch it, do so. If you need to Google it, do so. If you need to watch other YouTube videos, do so. Ask me questions, I'm here to help. But I need you to know that that is the skill that we're gonna have to be solid in before I go on to the next lesson. So make sure you're practicing. Again, as always, I hope you guys are staying safe. I miss you all. Bye.